Good evening, students. How are you all? So, welcome to Stuti Academy. So, today is the second class. Yesterday, we had started with real numbers. I hope you have revised the same. So, whenever you have a class, children, please make sure that you're prepared for the class. That means whatever we have discussed in the previous class, you should just take out some time and practice for the same. Even if you don't get time, please try to take out 15 minutes at least. And you can come up with your doubts in the next class so that I can clarify the same. So we started with real numbers. That's chapter 1 of grade 10 in yesterday's class. So we'll just quickly revise the same today. I just take 5 minutes to revise the same. So yesterday we had discussed right from scratch that we had studied natural numbers in primary classes, the counting numbers 1, 2, 3, 4, 5, 6 and so on. Then we had started whole numbers. So then 0 was introduced and then that was a new collection of whole numbers. In grade 7 and 8, we started rational numbers. Rational numbers are those numbers which can be written in P by Q form. And then in grade 9, we started irrational numbers. That means those numbers which cannot be written in P by Q form. So together, if we take rational and irrational numbers, that forms a new collection, that is real numbers. So rational numbers can be written in P by Q form. Irrational numbers cannot be written in P by Q form. And together, they make a new collection, that's real numbers. Now, lemma we discussed last time. It's a proven statement used for proving another statement. That means it's a statement which we've already proved and we use it to prove a particular theorem. Something else, some other statement, we use it to prove it. Now we have discussed Euclid's division lemma, which says given two positive integers a and b, there exist unique positive integers q and r satisfying a equal to bq plus r, where 0 less than equal to r less than b. So I discussed this yesterday also. So when we have two numbers, let's say a and b, where a is greater than b, a is bigger number and b is the smaller one, and we divide a by b, then we get a quotient q and we get a remainder r. And this can be written in the form of dividend. This is the dividend equal to divisor into quotient. This is the divisor and this is the quotient plus remainder. Now the remainder can either be 0 or remainder can be strictly less than the divisor. That means it can be strictly less than b in this case. So this we discussed last time. Also we had discussed Euclid's division algorithm to find HCF of two numbers. So HCF of two numbers we can solve by prime factorization method also. But in grade 10, we've learned how to find HCF of two numbers using Euclid's division algorithm. So this also we discussed with the help of two examples. We discussed this 135 and 225. I hope you've already practiced this. This is an NCERT question. We discussed this also yesterday. Also yesterday, we had used Euclid's division algorithm to do two questions here of NCERT. This one, show that any odd positive integer is of the form 6q plus 1 or 6q plus 2 or 6q plus 5, where q is some integer. And we had done this one also. Now children, please notice here, we are going to do this theorem, this question using Euclid's division lemma. So Euclid's division lemma says that if we have two integers a and b, then there exist unique positive integers q and r such that a equal to bq plus r, 0 less than equal to r less than b. Now using this lemma, we have to prove that use Euclid's division lemma to show that the cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. So we did discuss square also, the square case also, show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer. Today we are going to do the same for cube. So we are going to take a as any positive integer and we are going to take here b as 3. Please notice we are taking b as 3, we are not taking b as 9. Now we are going to apply Euclid's division lemma here. So we can write a as bq plus r, where 0 less than equal to r less than b. Now I'm going to replace b by 3. I've taken b as 3. So a is equal to 3 cube plus r, 0 less than equal to r less than 3. Now we have a is equal to 3 cube plus r. Now this 0 less than equal to r less than 3 means r can take the value 0, it can take value 1, it can take value 2. Please notice r cannot be 3 because r is strictly less than 3. So we cannot take r is equal to 3 in this case. Now as we did yesterday, we are going to do the same here. We'll take case 1 when r is equal to 0. Now when I put r is equal to 0 here, I'm going to get a is equal to 3 cube. Now the question says show that the cube of any positive integer. Cube means I'm going to take cubes on both the sides. So I'll take this as a cube and this is 3 cube. This can be written as 27 cube. Now children, please notice this 27 can be written as 3 times of 9 and this cube I am writing as it is. Now I can take this as m. So this is 3m. Also, we can write this as 9m also. Just see, since we have to write it as 9m, so I'm just interchange these two. I'll write here 9 times of 3 cube. So I'm going to take this as m. So this is 9m. So this 3m was the thing which we discussed yesterday. So this is 9 times of m. I'm taking 9m because that is what is asked in the question. So instead of 3 into 9, I've taken 9 into 3. So this is 9m. So finally, this a cube we have expressed as 9m, where m is 3 cube. That means m is any integer. So here we can say that cube of a can be expressed as 9 times of m. So it can be expressed in this form. Now children, we are done with the first part. In case 2, we are going to put r is equal to 1. So we'll take here case 2, that is r is equal to 1. So if we put r is equal to 1 here, we are going to get a as 3 cube plus 1. So a here is 3 cube plus 1. Now again we need cube of the positive integer. So we are going to take cubes on both the sides. So we'll get a cube is equal to 3 cube plus 1 cube. Now this is of the form a plus b whole cube. This identity we did in grade 9 also. A plus b whole cube can be written as a cube plus b cube plus 3ab into a plus b. So I'm just writing this identity. We'll be expanding this 3 cube plus 1 using this identity. So we'll write here a cube, that is 3 cube plus b cube, that's 1 cube in this case, plus 3ab into a plus b. Now I've put the values of a and b. Let us now simplify this. We'll get this as 27 cube. 1 cube is 1. Now this would be 9 cube, and 9 cube we are going to multiply with 3 cube plus 1. So in the next step, I'm going to take this 9 cube inside the bracket. So I'll get here a cube is equal to 27 cube plus 1, and this we are going to take inside. We will get 27 cube square, and this also we'll multiply with 1. We'll get 9 cube. Now as per the question, we need to put this either in the form of 9m or 9m plus 1 or 9m plus 8. So I am rearranging the terms. I am going to take these 3 terms together, and this plus 1 I'll keep it aside. So I'll get a cube is equal to 27 cube plus 27 cube square plus 9 cube plus 1. Now out of these 3, I'm going to take 9 common. Please notice q is also common, but that's not required because we just need to write it in terms of 9m plus 1. So only 9 is required. Q is not required. I'm not taking it outside. So this is 3 cube plus 3 times of q square plus q plus 1. Now in the next step, I'm going to express this as m. So this is 9 times of m plus 1, where m we have taken as 3 cube plus 3 q square plus q. That means m is any integer in this case. So finally, we have taken this A, and the cube of A can be represented as 9m plus 1, where m is any integer. Now this was our case 2. In the same way, we are going to discuss case 3. In case 3, we are going to take the value of r as 2. So we are done with 0, we are done with 1, we are now left with 2. Once we put r is equal to 2, we will get 3q plus 2. So here we will get a is equal to 3q plus 2. Now again, I am going to take cubes on both the sides. So I will get here a cube is equal to 3q plus 2 cube. And then I am going to expand this using a plus b whole cube identity. So I just write it again. A plus b whole cube can be written as a cube plus b cube plus 3ab into a plus b. So I'll expand this now. I will get a cube is equal to 3q cube plus 2 cube. So I'm just putting the values of a and b. For me, a is 3q and b is 2. So I'm just putting the values here. So we have 3 times of 3q into 2 into 3q plus 2. Now we can write 3q cube as 27q cube. This 2 cube is 8. We can multiply all of these. We'll get 3 into 3, that's 9. 9 into 2, that's 18. 18q into 3q plus 2. Now we'll take this inside and we'll multiply with each term inside the bracket. So we will get a cube is equal to 27q cube plus 8 plus 18 into 3, that's 54q square, and 18q into 2 will give us 36q. Now I'm going to express this in the form of 9m plus 8. 9m plus 8. So I'm rearranging the terms. I'll take these 3 terms together and plus 8, I'll keep it aside. So I will get a cube is equal to 27q cube plus 54q square plus 36q plus 8. So I've just rearranged the terms. Now from these 3 terms, I'm going to take 9 common. So I will take 9 common here. So I'll be left with 3q cube plus 6q square plus 4q plus 8. Now in the next step, I'm going to express this as m. So this a cube is 9m plus 8. So a, that positive integer which we took, now we have shown that the cube of a can be written as 9m plus 8, where m is any integer. So finally, now we have proved that cube of any integer can be expressed as 9m or 9m plus 1 or 9m plus 8. So we got 9m when r is equal to 0. We got 9m plus 1 when r is 1. And we got 9m plus 8 when r is 2. Okay, so we are done with this question. Children, please, all of you at home, do practice this question because this is something very new to you. So please practice before you come for the next class. And wherever you have a doubt, please ask. So you will get similar questions in the exam also. And you will get similar questions you will see in NCERT in examples also. Please go through the same. Now coming to fundamental theorem of arithmetic. This I discussed yesterday also. So since we'll be using this in today's class, so I'll just quickly review this. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Now this means if I take any composite number, I can put it in the form of prime factors. So I discussed prime numbers and composite numbers yesterday also. Prime numbers are those numbers which have only 2 factors, like we have 2, we have 5, they have only 2 factors, 1 and the number itself. And composite numbers are those numbers which are not prime numbers, like they have more than 2 factors. For example, we take 10. 10 has factor 1, 2, 5 and 10 itself. So it has more than 2 factors. It has 4 factors here. So every composite number we can factorize as the product of prime numbers. Now please notice I've taken here 18 as a composite number, and I've written it as 3 times 3 times 2. 3 into 3 into 2, I've written this. 3, 3, 2, they're all prime numbers. So I've put this in the form of product of primes. Now this prime factorization is unique. By unique means I can express 18 as product of 3, 3 and 2. Nothing except that. I cannot write 18 as 5 into 7. That's not correct. 5 into 7 is 35. I cannot write 18 as 2 into 3. That is also not possible. So this prime factorization is unique. We can write 18 as product of 3, 3 and 2. And then it's given here in the statement, apart from the order in which the prime factors occur. The factorization is unique apart from the order in which the prime factors occur. This means that the prime factors can be anything. We have 3, 3 and 2. We have a specific 3, 3, 2. We cannot change it, but we can rearrange them. We can write 3, 3, 2 as 2, 3, 3 or 3, 2, 3. We can change the places. We can rearrange the terms, but the factors, they have to be the same. Now children, we can rearrange the terms because multiplication we can do in any order. If I take 3 into 2 or if I take 2 into 3, it will give me the same result. That is why we can rearrange the factors, but then we cannot change the prime factors. Now we'll be using fundamental theorem of arithmetic in the next question. This is also NCERT question, exercise 1.2. Express each number as product of its prime factors. So the first part here is 140. We have to put this in the form of product of prime factors. So I'm going to factorize this. I'll start with 140. I think this you already know. You've done this in primary classes also. Usually we start with least possible prime number. So we are going to start with 2 here. We'll get 70. 140 divided by 2 will give us 70. We'll again divide by 2. We'll get here 35. We are going to again divide by the next prime number would be 5. We cannot do it by 2, not possible. It's an even number. 3 is also not possible. We'll do it by 5. So 35 divided by 5 will give us 7. And finally 7 will go by itself. And we have reached 1 here. Once we get 1 here, we'll stop. These are the prime factors of 140. So 140 can be written as 2 into 2 into 5 into 7. So 140 we can write as product of these prime factors. We can also write this as, this 2 into 2 we have, we can write this as 2 square also. If you want, you can write it like this. Okay. Now we'll do the same in the second part. We have 156 here. That's the second part where we again have to prime factorize this. So we are going to start with this 156. As we can see, it's an even number. We'll start by 2. So we'll write here 2. And then we'll get 7 here. And then 8. 78. 78 again is an even number. We'll write here 2. And then we'll write here 3. Then 9. 39. Now 39 will go by 3. We'll get 13 here. And finally 13 being a prime number will be divided by itself. So finally 156 we can write it as 2 into 2 into 3 into 13. So we have expressed 156 as product of prime numbers. Now let us proceed. Okay, so here we have a bigger number, 3825. So let's see, 3825. As I told you that we usually start with least possible prime number. So we'll first try to do by 3. 2 is not possible. It's an odd number. It's not divisible by 2. Let's start with 3. Let's see if we can do it by 3. Yes, we can do it. How did I figure out that this is divisible by 3? I have added the digits here. So 3 plus 8 will give us 11. Plus 3 will give us 13. Plus 5 will give us 18. So 18, the sum of the digits is divisible by 3. So this number is also divisible by 3. So we'll get 1 here, then 2, then we'll get 7 and then 5. Now this will again go by 3. This would be 425. Now 425 is not divisible by 3. So we'll do it by 5. So we'll get here 85. 85 will also be divided by 5. So we'll get here 17. 17 is a prime number, so this will go by itself. Finally, we have 3825 as 3 into 3 into 5 into 5 into 17. You can also write it as 3 square. This can be written as 5 square, and 17 we can write as it is. So this is 3825. We can write it as 3 square into 5 square into 17. So children, this is very simple. You've done this in primary classes also. Now coming to the last one, we have 5005. So this also we have to prime factorize. So this is not divisible by 2. It's an odd number. This is not even divisible by 3. Let's try with 5. 5 it is possible because we have 5 in the ones place. So we'll get 1001. Okay. Now 1001, this is not divisible by 2. It's an odd number. Not even divisible by 3. Not divisible by 5. Let's try with 7. Let's see if it's possible. So this is going to go 10. We'll get 1 time. Then we have 3 as the remainder. This will become 30. So this will go 4 times 28 we have, and then finally 3. Yes, this is completely divisible. Now 143. Let's try this one with 11. So this will go 1 time and then 3, 13. 13 we know it's a prime number. This will be divisible by itself. So we'll get 5005. This can be written as 5 into 7 into 11 into 30. So we have expressed this in the form of prime numbers. Okay, so now we are well versed with prime factorization. Let us proceed further. Now, children, in primary classes, we have learned how to find the HCF and LCM of two numbers, or 2 or more numbers, in fact, using prime factorization method. Now, HCF and LCM we already know. Let's talk about just 2 numbers for the time being. If we have 2 positive integers, A and B, then the HCF of A and B you take, and you take the LCM of A and B. And when you multiply these two, this will be same as product of the numbers. So HCF of 2 numbers multiplied by LCM of those 2 numbers will be same as product of the numbers. For example, if we have 26 and 91, these 2 numbers we are taking. 26 can be written as 2 into 13. 91, if we prime factorize, we'll get 7 into 13. Now, as we can see, 13 is the common factor here, and that's the only common factor. So the HCF of 26 and 91 is 13. Now, when we take the LCM of these 2 numbers, if we prime factorize 26 and 91 together, we'll get 2, 7 and 13. And this will be multiplied and we'll get 182 here. So we need to check whether HCF into LCM is same as the product of the numbers. So I'm taking the HCF 13, I'm taking the LCM 182, and I'll multiply these 2. So we'll get 2366 here. Also, if I take the numbers given to me, 26 and 91, and I multiply, I will get 2366 here. So we have now concluded that the HCF of 2 numbers into the LCM of these 2 numbers will be same as product of the numbers. Now children, we'll be applying this concept in the next question. We have to find the LCM and the HCF of the following pairs of integers, and we have to verify LCM into HCF is product of the numbers. So we have 2 numbers, 510 and 92. So in order to find the HCF, we have to prime factorize 510 and 92 separately. So I'm going to take this 510. It's an even number. I'll divide by 2. I'll get 255. 255. Now this 255 is divisible by 5. We will get 51. 51 is divisible by 3. We will get here 70. And 71 will go by itself. Now let's prime factorize 92. We have 92 here. And then we are going to divide by 2. We will get here 46. We'll get here 46. This will be divisible by 2. We'll get here 23. And 23 is going to go by itself. Now 510, we can write it as 2 into 5 into 3 into 17. And 92, we can write it as 2 into 2 into 23. Now children, please notice, let us figure out the common factors here. 2 is factor of this and 2 is also factor of 92. We have no other common factor. So since there's no other common factor, we'll consider 2 as the HCF only. So HCF of 510 and 92 is 2. Now we've got the HCF. The next step is we are going to solve for the LCM. So we'll solve for the LCM. When we solve for the LCM, we are going to prime factorize 510 and 92 together. So this will go by 2. We are going to get here 255 and we'll get here 46. I hope you know this. You've already done this in grade 5 and grade 6. Now 255 is not divisible by 2, but this is divisible by 2. So we'll divide by 2. We'll get 255 and this would be 23. Now 255, we can see it's divisible by 5. We are going to get here 51 and then 23. Now 51 is divisible by 3. We'll get here 17 and then 23 here. So 23 and 17 are both prime numbers. So we'll first write 17 here and then we are going to write 23 here. So we'll get here 23 and then 1, 1. Finally, the LCM of 592 would be product of these factors which we have got. So when we are going to take the LCM of 510 and 92, we'll get here 2 into 2 into 5 into 3 into 17 into 23. Now once you multiply all of these, you will get 23460. So I'm just giving you the direct answer. You'll have to multiply this and then 23,460 you will get as the LCM. Now as per the question, we need to check LCM into HCF is product of the numbers. So I'll take the HCF 2 and the LCM we've already solved this. So let's see, LCM into HCF is 23460 times 2. Now when you're going to multiply these two, you will get 46920. This you're going to get. Now this is same as product of these two numbers, the given numbers. So if you're going to take 510, you'll multiply it with 92, you will realize you're getting the same number, 46920. Children, you must get the same number in this case. If you're not getting the same number, that means you've made a mistake. So you can just straight away figure out where is your mistake. You might have you might make a calculation error in that case. So here we have HCF into LCM and the product of the numbers, they will come out to be the same. Again, I'm repeating, they must be same. If they're not coming out to be the same, that means you made some mistake. Okay, so this concept is very, very important because we are going to use this further also. So let's quickly do one more verification question. So this is this third part of exercise 1.2 question number 2. If you have your NCERT textbook, you can refer that. So we have 336 and 54 here. We have to again find the HCF and LCM and then we have to check this. So let's quickly find the HCF. We are taking 336. We'll divide this by 2. We'll get 168. Then we'll divide by 2. We'll get 84. Then we'll divide by 2. We will get 42. Then again we'll divide by 2. We'll get 21. And then this is divisible by 3, 7 and 1. That's how we're getting. Now 54, this is quite simple. You can divide this by 2, you will get 27 here. Then by 3, you will get 9 here. Then by 3, you will get again 3 here. This is divisible by 3 only. So now 336 can be written as 2 into 2 into 2 into 2. There are 4 times 2. We have 4 2's here. And multiplied by 3 into 7. And 54 can be written as 2 into 3 into 3 into 3. Now let us figure out the common factors. We have 1 2 here, we have another 2 here. We have 3 here, we have one more 3 here. That's all. We don't have any other common factor. So HCF of these two numbers would be 2 into 3. Please notice that's a very common mistake. Children feel that 2 is the common factor, 3 is also the common factor. So 3 is the bigger one. So that's the HCF. Please notice you will not do like this. HCF of these two numbers given to us, where we have two common factors, we have 2, we have 3 also, we will straight away multiply these, and the product, that is 6, would be the HCF of the given numbers. I hope you've understood till here. You've done this in primary classes also. Okay, now coming to the next step, we are going to solve for the LCM of 336 and 54. So we'll prime factorize this, 336 and 54. So for HCF, we do the prime factorization separately, and for LCM, we take both the numbers together. So both of these, they're divisible by 2. If I write 2 here, I'm going to get here 168, and I will get 27 here. Now this is divisible by 2. We'll get here 84, and this is 27 is not divisible, so I'm just copying as it is. Now this is by 2, we'll get 42 here, and then 27, and this is again by 2, we'll get 21 here, and then 27. 21 and 27, they're both divisible by 3. So we'll divide this by 3, we'll get 7, and then we have here 9. 7 will go by itself, and then we're left with 9. 9 will go by 3. So 1, 3, and then again, we can just do it 3 here, 1, 1. So in order to solve for the HCF of the given numbers, we'll multiply all of these. So the LCM would be 2 into 2 into 2 into 2. So we've taken 4 2's here, and then we have 3 into 7 into 3. Now once you're going to multiply all of these, you're going to get the LCM as 3024, 3024. This is the LCM which you're going to get. Now you have the LCM here, and you also have the HCF, that is 6. Now we'll take the LCM into HCF. That means we'll take 3024 times 6. So this will come out to be 18144, 18,144. This is what we have got. Now coming to the original numbers, we have 336 and 54. If we multiply these two, we will again get 18,144. So finally, we have arrived at the conclusion that HCF and LCM of two numbers, if you take, you multiply them, you will get the same result as the product of the given numbers. Have you all understood this, children? Yes. So this one is very simple. HCF and LCF you've already done in primary grades. And then you have just checked this result. Okay. Now coming to the next question, which is based on the same concept. Given that HCF of 306 and 57 is 9, we have to find the LCM. So children, we know that HCF of two numbers and LCM of two numbers, if we take, it is same as the product of the given numbers. So here in this case, HCF we know is 9. I'm going to replace this by 9. And LCM I need to solve for. So I'm just writing LCM here. Now there are two ways of doing it. Either you multiply this, make your calculations tedious, and then you divide by 9. So that will be a very lengthy process, and the calculations would be tedious. You can just take this 9 here. Don't multiply right now. Let's see if any cancellation is possible. So we'll take LCM is equal to 306 times 657 upon 9. Now let us see if anything can be cancelled. In fact, this 657 is divisible by 9. It is divisible by 306 also. So you can cancel any one of these. So 9 will go by itself one time, and this is going to go 3 times 27, and then we have 34. So LCM here is 34 into 657. When you're going to multiply these two, let us see what do you get here. When you're going to multiply these two, you are going to get 22338. This is what you're going to get, 22338. So this is the LCM. That is the answer. So children, please notice, such questions, they do come in the exam where you're given two numbers, you have to solve for the HCF. So we have the HCF here 9. In that case, when the such questions come in the exam, so either one of the numbers is given to you and you have to figure out the other one, or they give you both the numbers and they give you any one of the HCF or LCM. So you have to find the other one, the unknown. Like in this case, HCF was given to us 9. The numbers also we were knowing, we were supposed to solve for the LCM. So we have used this condition here. Okay, so we're done with this. Now the next question, this is very, very important, and also this can come in different forms. And this is a very logical question. Check whether 6 raised to the power n can end with digit 0 for any natural number n. So a number ending with digit 0 means it should have 0 in the ones place. So 6 raised to the power n, we want to end with digit 0. So if a number has 0 in the ones place, can we say that 10 is a factor of that number? Can we say that? Yes, we can say that. If I have 50, we have 0 in the ones place. I can say 10 is a factor of 50. Now, if 10 is a factor of 50, can I say 2 and 5, the prime factors of 10 and 10, they're both factors of 50? Yes, they are. So for a number to end with digit 0, it should have 10 as its factor. Further, we can say that 2 and 5 must be the prime factors of that number. Now let's take the number which is given in the form of 6 raised to the power n. Now we know that 6 can be written as 2 into 3. We can write 6 as 2 into 3 raised to the power n. Now this can further be written as 2 raised n into 3 raised n. So now we can say that 6 raised n is 2 raised n into 3 raised n. So we can say that the prime factors of 6 raised n, we have 2's and 3's. So we have 2, but then we need to have 5 as well. If we have 5, then only 10 will be factor of that number. But then we don't have 5 here. So here, prime factors of 6 raised n, we have 2, but we don't have 5. We need to have 2 and 5 both. So it is not possible. It's not possible that 6 raised to the power n can end with digit 0. So not possible in this case. So you will just prime factorize this number and you will check the prime factors. If you're getting 2 and 5 both, then you can say that yes, it ends with digit 0. But then if you don't have, suppose you have 2, but then you don't have 5, or you have 5, you don't have 2. You need to have 2 and 5 both. So if any one of these is missing, then we can say it cannot end with digit 0. So such questions, they can come in different forms. You can either get 6 raised n, you can get 12 raised n, or you can get 4 raised n. So you will see variety of questions here. Okay, now let us proceed. Coming to the next one. So this one is also very simple. I've just discussed the composite numbers and prime numbers with you. So I'll just quickly revise the same. Prime numbers are those numbers which have only 2 factors, 1 and the number itself. Composite numbers are those numbers which have more than 2 factors. So we have to explain why this and this, they're composite numbers. So I'm just taking the first part here. So there are 2 ways of doing it. Either you take 7 into 11 into 13, you multiply, you add 13 to it, you will get a big number, then you prime factorize it, and then you say that yes, it has a lot of factors, so it's a composite number. But that's quite tedious, so we'll go very logically here. So we'll avoid any hectic calculations here. Now, can I say that 13 is common here? Yes, it is. 13 we can take common. And then we'll have 7 into 11 plus 1. If you want, you can write this as 7 into 11, that's 77. Plus 1, you will get 78. So whatever the number is, you don't need to multiply 13 and 78. That's not required. Just by looking at this, you can say 13 is a factor of this number. 78 is also a factor of this number. So we can say that it has more than 2 factors. We are not just talking about 13 and 78. Please notice every number has 1 as a factor. Also, every number is its own factor. So we have those 2 factors in any case we have. Also, we have 13 and 8 just by observing, 13 and 78 just by observing this. So we can say it's a composite number since it has more than 2 factors. We'll do the same in the next part also, where we have 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So this is one term and this is another term, and we can see that 5 is common. So we'll take out this form common and we'll write here as 7 into 6 into 4 into 3 into 2 into 1, and this 5 we've taken outside, so we'll write plus 1 here. Now whatever the number is, we don't need to solve for the number, not required children. Just observe that 5, this number can be written as 5 times of something. So we can say that 5 is a factor of this number. So for this number, we have 1 as the factor. That's very obvious. The number is itself its own factor. And then we can see that 5 is also a factor of this number. We have more than 2 factors in this case. So this is also a composite number. All right, children, I think it's enough for today. And when you come for the next class, please make sure that you have revised well. Wherever you have a doubt, please ask me in the next class. Please take out some time and practice questions from NCERT for the time being. All right, children, thank you so much. I had a wonderful session with you, and I hope the concepts are clear to you.